So we're here today to launch the Architects of Modern Power, the AMP Consortia, together with CUI and Murata. If we back up, Ericsson has been researching and developing digital power for 10 years. We launched our first digital power module in 2008, and we launched some point of loads the year after. Very quickly we got the feedback from customers that customers were looking for second source. We also realized that this is a disruption in the market, and the disruption meaning that it will take more than one player to actually develop the market. And out of all of that came the idea of collaboration and where we are today with Architects of Modern Power. Digital power makes it much more easy for a board designer to design the power. Board designer today works with software and designs his board or her board from a software perspective. And with the GUI that we bring into the software, the graphical user interface that we have developed makes it much more simpler for the engineer to design the power in a way that engineer is used to working with his design anyway. For an engineer working with their boards, instead of ordering some parts, realizing I ordered the wrong parts and having to reorder, they will instead go back to the design board, change some parameters, download it into the module, and redo their experiment. So only there they will save a lot of time. Ericsson is extremely excited about this. We see a disruption in the market with digital power. We are at the forefront, and now we have two strong partners in this consortia that will help us make this happen.
So the complexity of power with the more and more FPGAs being put on a customer's board, DSPs, ASICs, it requires a very complex power design. A lot of features, and if you were to do it in an analog approach, it's a lot of components the customer would have to put on their board. From a digital point of view, a lot of that's built into the power supply itself. So the software component adds power functionality that really cannot be achieved in an analog solution. You know, one of the issues in the digital power industry is there's not been any standardization. So through this consortium, we're creating software and hardware standards from a footprint and configuration files and a software point of view. So from a supply chain base, a Murata part, an Ericsson part, a CUI part, will all work interchangeably in the socket. So truly a customer can pull one part number and assign all three suppliers to it. The analog engineer that has typically designed power in the past is sort of a thing of the past. There's more and more digital designers out there. So what we make is, through our graphical user interfaces, power systems easy to design. So the end user can go in, define a very complex power system in a very short period of time. A lot of automatic features within our GUI software are taken care of, where a power design engineer in an analog fashion would take quite some time to implement that same type of functionality. And then through digital design, you have simulation of the power system, so the customer ends up with less board spins in the end, so they get their product to market quicker.
You know, we're excited about AMP because it really solves a problem in the industry. The digital realm of point of load and intermittent bus converter changes everything, because when you look at a multi-source engagement, it's no longer just a mechanical aspect. It has a controller, it needs to be programmed, and it changes the game when you're trying to have a supply assurance program at the customer base. This is really just a formalization of something we've been working on for 4 to 5 years. Behind the scenes, we've worked to try to satisfy our customers' needs for multi-source. Often we always go into a customer, and one of the first things they say is, do you have an alternate source? And we have had an alternate source. This is just a formalization of that to make sure that it's a seamless process for the customers, and that we implement everything along the way to make sure that there's no production issues, no second source issues, and they get their issues solved. it's important to us to make sure that we're driving forward. So for us, it's not only just releasing the standards that we did today, it's also about moving forward. So we're driving a roadmap. So this is a very tight consortium working together. We have involvement from all levels, whether it's marketing, management, and as well as engineering. So we're going to be working with the industry to understand what is needed next. We want to make sure we're on the forefront of the need, not only from the multi-source aspect, we have that taken care of, but now we can say what's the technology needed, because in the market today, it's about perfect power conversion. It's no longer about just converting one voltage to another voltage. That voltage has to be perfect under all conditions. And every FPGA or DSP company out there defines that definition different. So we need to make sure we have that information so that our roadmap is driving to that. Digital power is going to grow anywhere from 3.5 to 5x if you look at some of the most recent studies. And the significance of that is that typically it's been dominated by the telecommunications market. They've been the early adopters. This new growth is going to come out of a new segment of customer. It's going to be the medical customers, it's going to be the instrumentation customers. It's everybody that's using the new FPGAs or DSPs that now require a digital core voltage. So now they no longer have an option. They will have to implement a digital solution. So in this growth segment, they've been kicking and screaming for a while, not wanting to necessarily implement it. Now they have to. So we're providing them an option to do that from three vendors, three of the industry leading vendors, as well as allowing them the supply assurance program so they're not in a proprietary position.